Did you know your fridge nearly killed life on Earth?
Hello, in today's podcast, Maya,
Hi.
Teresa,
Hey.
and I, Esther, are going to talk about how we, humanity, managed to save the ozone layer. Maya will introduce you to the ozone layer and the discovery of CFC'S. Teresa will talk you through the chemistry of ozone depletion, and I will explain how the world came together to prevent further damage.
So first, it's important that we're all clear on what the ozone layer is. Ozone was first discovered in the 19th century, when a German scientist named Christian Friedrich Schönbein noticed a strange smell when lightning hit the ground. He later found out that a particular chemical was responsible for this. He named it ozone, after the Greek word which means to smell. We now know that ozone is a molecule that contains 3 oxygen atoms, so it's written as O3. Whereas oxygen molecules in the atmosphere are generally made up of 2 oxygen atoms, so each molecule is O2. So how is ozone formed? A British chemist, Sidney Chapman, illustrated it as a cycle. When oxygen molecules float in the atmosphere, they can become exposed to ultraviolet light. And this light breaks the bonds that hold an oxygen molecule together to produce 2 separate oxygen atoms. And these separate oxygen atoms then collide with oxygen molecules, each containing 2 oxygen atoms, and form bonds which leads to the formation of ozone. When the ozone molecule is also exposed to ultraviolet radiation, it too splits into one regular O2 molecule and a free oxygen atom. The oxygen atom will collide into an ozone molecule, which will end up splitting it. Finally, this forms 2 oxygen molecules. Then the cycle repeats and repeats. So this is a normal process in the atmosphere that keeps the number of ozone molecules to a tiny fraction of the number of regular ozone molecules. There are about 3 ozone molecules to 10 million oxygen ones. Earth's atmosphere is composed of several layers. The lowest layer is known as the troposphere, which is where we live. It goes from Earth's surface up to 10 kilometers in altitude. The highest mountain on our planet is only about 9 kilometers high. The next layer is the stratosphere. Here's where we find the ozone layer, which is a concentration of ozone molecules. Around 90% of the planet's ozone is in the ozone layer. This layer absorbs some of the radiation from the sun, which protects our planet. Most importantly, it absorbs ultraviolet B, a very harmful type of ultraviolet light, which Teresa will talk to you about later on. So, the ozone layer acts as a barrier against ultraviolet radiation from the sun. It is so important. It's Earth's sunscreen. Now that you guys know the basic science behind the ozone layer, we can get back to the ozone crisis. We have to go back to the 1920s. The proportion of U.S. homes with electricity increased in that decade from 25 to 80%. This was seen by major manufacturers as a chance to create more electrical appliances. Many manufacturers chose to replace iceboxes with electric fridges. This change took a while, because not only was the appliance expensive compared to an icebox, but it was also risky. Toxic and highly inflammable gases such as sulfuric acid and ammonia were used as refrigerants, which are fluids that can easily evaporate and condense continuously to absorb heat, so making things cold. These toxic gases could leak and make food go off. So in 1928, American engineer Thomas Midgley came up with a great solution. He invented a new refrigerant called a chlorofluorocarbon, or a CFC for short. These compounds contain the elements chlorine, fluorine, and carbon. He even proved they were neither toxic nor inflammable by inhaling some and then blowing out a candle without any trouble. These gases were revolutionary. They were non-toxic, non-inflammable, tasteless, durable, and they didn't easily react with any other chemicals. They were used as refrigerants for fridges, cars, and air conditioners, as well as in cleaning agents and foaming agents for insulation. They were ideal gases.
But what Thomas Midgley didn't know was that CFCs caused the ozone layer to thin, exposing life on Earth to UV light. The ozone layer plays a crucial part in protecting us from harmful ultraviolet rays from the sun because it absorbs about 50% of UVA light that is responsible for premature skin aging and about 90% of UVB light. But the 10% that make it through are responsible for sunburns and skin cancer. Ozone absorbs 99% of UVC, which is the most dangerous type of UV light. So without the ozone layer, people, animals, and plant life would be destroyed. But how exactly do CFCs break down the ozone layer? This part is a bit tricky to understand, so pay close attention. CFCs are made up of atoms of carbon, chlorine, and fluorine. Because CFCs are gases, they can escape from poorly sealed containers into the atmosphere. Once in the upper atmosphere, a chain of reactions occur that destroy ozone. High-energy ultraviolet rays break chlorine atoms free from the CFC molecule. When chlorine reacts with ozone molecules, it steals one of the ozone molecules' 3 oxygen atoms, forming a molecule of chlorine monoxide. The remaining 2 oxygen atoms form an ordinary oxygen molecule. This is how an ozone molecule is destroyed. Chlorine monoxide reacts easily with single oxygen atoms in the atmosphere, leaving a free chlorine molecule that can destroy more ozone. Scientists estimate that 1 chlorine atom can destroy as many as 100,000 ozone molecules. Thomas Midgley had the choice between CFCs and BFCs. The 2 molecules are equally as good in their capacity to carry heat and cold. The industry chose chlorine instead of bromine, which is 50 to 100 times more damaging on the ozone layer than chlorine, which means we would have understood the problem too late. Without even knowing it, we would have pushed the planet over an irreversible point. Areas of damage in the ozone layer are called ozone holes, but this name is misleading because ozone layer damage is more like a thin patch with the thinnest areas near the poles. The ozone layer above the Antarctic has been impacted by pollution since the mid-1980s. The region's low temperatures speed up the conversion between CFCs to ozone-damaging chlorine. In the year 2000, it was estimated that this hole was responsible for 1 million cases of skin cancer. It threatened to increase cataracts, which is the blurring of the lens of your eyes, and it also threatened to damage plants, crops, and ecosystems.
Paul Crutzen was one of the scientists who discovered the impact human society had on Earth. Industries who used CFCs tried to suppress his research, but in the end he made public his research on the ozone depletion. Countries across the world recognised that the depleting ozone layer was endangering life on Earth. According to NASA, if nothing had been done, we would have lost 17% of global ozone layer by the year of 2020. In 1985, 197 countries signed a treaty called the Vienna Convention for the Protection of the Ozone Layer. This was the first treaty that was ratified worldwide. The aim of this convention was to globally minimise the use of CFCs. Following the Vienna Convention was the Montreal Protocol in 1987. 24 countries, led by the CEE, agreed to ban CFCs and use substitutes instead that were less harmful for the ozone layer. Since then, the protocol was revised 9 times, banning more and more CFCs. Its latest was in 2016 in Kigali, capital of Rwanda. More and more countries joined the agreement and signed the protocol. Today, there are 197 countries who agreed to the convention. Crutzen was awarded the Nobel Prize in 1995. He continued working, this time on climate change. He came up with the term Anthropocene, defining a period where humans have had a substantial impact on Earth's climate and ecosystem. He died a few months ago on the 28th January 2021. The ozone layer is now recovering, and we expect it to be completely healed between 2050 and 2075. Most CFCs are now banned or illegal. Yet the fight is still not over. Some of the substitutes that are used instead of CFCs are greenhouse gases and contribute to climate change. Although we have tackled a great danger to life on Earth, we have triggered a new one. The ozone depletion, like climate change, is an environmental crisis. It was dealt by bringing every country together to fight for the same cause. The climate change crisis will have to be dealt in the same way. The big difference with climate change is that we have to deal with more than one factor.
This podcast is based on the 5th chapter of Facing the Anthropocene by Ian Angus. If you're interested in learning more, you should go check out the book.
Feel free to have a look at the Cut 11% website and Instagram page. Thank you for listening to the Climate Breakdown. Demand governmental action, demand the right to know, and cut 11%.